rotation is when you have an angle and your starting off point, your initial side, is on the positive part of the x-axis. Your initial side, again, is that positive part of the x-axis. This is where our angle is always going to start. It's never going to start anywhere else. The terminal side is where it terminates or ends. And depending on which way you rotate, gives us a positive or a negative angle measure. So if we rotate counterclockwise, it's positive. Clockwise is negative. Coterminal angles are when you have the same angle picture. So you've drawn a picture of an angle, but how you get to that spot is different. So one of the things that I always give as an example is, let's say I told you guys that I want you to run to QD. And whoever gets there first gets an A triple plus, and you don't have to do any more work the rest of the year.
Really?
I got a lot of people who looked up and were like, yes, tell me more.
I mean, I'm not complaining.
I see that. A couple people woke up. Okay. If I told you that, and I said you're starting here, right, our starting spot is this classroom, and your ending spot is QD, would you all probably run the exact same way to get there? Would you take the same route? Probably not.
No, because I would take a straight away.
You would still, right, you would try to take the shortest way possible. But you have the same starting and ending point.
That's true.
And that's what coterminal angles are. They have the same starting and ending point, but how you get there is different. And we'll, like I said, we'll look at some examples in just a minute. Here's the other thing I want you to write in on this graph before we do anything else. If I rotate 0 degrees, it'd be right here, because it would be like me rotating nowhere. I just live at that line. What if I rotated up to here? How far is this rotation? If I were to make my angle zoop zoop like this.
That would be
90 degrees. Good. What if I rotated halfway around this circle and I went shh, all the way to here? 180. Perfect. Down here, we would have to add another 90, so this would be 270 degrees. And what if I did a full rotation? I spun around once.
That would be 360.
360. Okay. So let's have all those things there for starters, and we're going to do a couple practice problems that involve that information. So one of the things that you need to be able to do is draw me an angle. So we're going to start with that. So when you're ready, go ahead and flip this sheet over, because there are some examples on the back, and we're going to practice drawing an angle.
I could go a 50-degree angle.
Wow. We're gonna get there. So give me some axes. So give me a graph for each one of these. Please give me an X and a Y. So start with that for these first couple. Now, I'm going to use a highlighter so I have a different color. If anybody else wants a different color, you can come grab a marker off my desk, or you can come grab a highlighter or whatever you'd like. I've got a bunch more highlighters right here. I can't use yellow though, because yellow and blue together are not okay.
No.
So I'm going to use green. All right, so every angle that I'm going to make starts here on the positive part of the x-axis. Now, we know this is 90 degrees, yes?
Should be.
Okay. I need to go just to 50. So would you agree it's just a little over halfway?
Yeah.
Okay. So I'm going to draw an angle that looks a little over halfway. Do you agree my angle looks like that? I'm not going to come get out a protractor and measure and say, oh, that's actually 52 degrees. That's wrong. I'm not going to measure. We're just making it, we're estimating. We're making it look like it's about 50 degrees.
We're making an educated guess.
Yes. Now, here's the other thing you have to put in there. So we've got our angle. It's about 50 degrees. We have to say how we got there. I started there and I went this direction, because that direction, that counterclockwise, is the positive direction. So this way is positive. I have to go that way if I'm making a positive angle. All right, next one. I have to start here. every single time, right? It's kind of like Monopoly. You don't pick where you start. You don't start on Boardwalk, do you? No, you start on the start space every single time. Same with this. All right, negative 120. So this time, instead of going this way, I gotta go the other way. Okay, so we're going the other way because it's negative. If I went this far, how much would this be?
270.
Well, no, we're going backwards. So this would just be, if I went here, negative 90.
Oh, okay.
Okay, so how much more do I need to go? Because I need a little bit more
A little more.
than negative 90.
Keep going.
Keep going. I need about 30 degrees more. So I'm going to go about right there.
Dang, so like everything flips basically when it's a negative?
Yes.
Okay.
Yes. Yep, so you just go the other way. So this one is starting at 0. This would be negative 90, and then I tried to make it look like about 30 degrees more. Right? So here's my 90 degrees, and then I tried to go about 30 more beyond that. Okay. Next, this one starts in the same spot. No surprise. Ooh, look at that number.
How does one
Ooh.
achieve?
Ooh. So this makes me think back to when we were like little kids and we'd like spin in circles and then try to walk in a straight line. Okay, that's what we're having right now is one of those moments. So let's pretend for a moment that I did one whole spin. How much is one whole spin? 360. How much further do I still need to go though? 40. So I'm going to draw about a 40-degree angle and watch how I'm going to show how I got there. I did a full spin and then I kept going.
Oh, you made yourself really dizzy.
Yes. So I did a full spin all the way around and then I went even just a little bit further.
I got it.
Okay. All right. Now, I'm only going to make us do one coterminal angle for each. Okay, so you can switch that from 2 to just 1. And I'm going to have you switch it on the homework as well. All right, so coterminal angles mean you're going to end in the same spot, but how you get there is different, right? I use my example of like running to QD, right? So it's that same idea. Okay, so here is my picture. I'm going to do the first one, and then you're going to help me brainstorm the next one. To get to this same angle, could I have done what I did here? Could I have gone around once and then gone to 50 degrees and it'd be the same picture?
Yes. Maybe.
Yeah, the angle would be the same. How I got there is different. So, if I want to go around once, what would I have to add to the 50? 360. So if I add that on, 410 degrees would result in the same picture. Now, the swirly part of it, this little swirl, would look different, right?
Yeah.
It would be like zoop, zoop. But in terms of how the angle looks, the initial and the terminal side would stay the same. Does that make sense?
Yeah.
So 50 degrees and 410 degrees are coterminal angles because they give me the same picture.
Why didn't you just start doing this?
Do what?
Just like the math in general. Like, where'd you?
Because there's a second part. It wants me to say what the coterminal angles are.
Okay.
And we can ignore the rest about positive and negative. I'm not going to make you do all that. We're just going to, bless you, we're just going to find one coterminal angle.
All right, bet.
Okay? So the next one, we started at negative 120 degrees. So I went this far. What's another way that I could get to that same picture? So let's brainstorm.
Like the other way.
I could go the other way. Yeah, I like that. So if I went the other way, I want to know how to get there. So instead, if I go this way, it's going to be positive, right? Okay. So do I make it the full way around if I go the other way?
Yes.
No. I'm 100. Do you see how I'm 120 degrees short of going a full revolution? So I would do for this one, I would do 360 minus 120. So if you're 120 degrees short, that's going to give me, how did I get there? 240 degrees. So again, if I want to go this way instead, I was 120 degrees shy of making a full twist.
Do we gotta put plus?
You don't have to put plus. I'll assume it's positive. I just wrote it to make it super evident. Now, let me show you another one, because there are actually infinitely many answers that you could have for these problems. Do you see how it's already negative 120?
Yes.
Could I have spun around once negatively and then gone to negative 120?
Yes.
Yeah. So I could also have for an answer negative 480. That could be another answer. So there are infinitely many answers, because you could keep adding or subtracting 360.
Alrighty.
Okay, look at the next one. Do you see how I did a swirl and then went here?
Word.
What's another way I could get the same picture?
400 plus 360.
Yeah, you can just add 360 every single time. That's kind of the trick. If it's positive, all you have to do is add 360, and you're going to get an answer. That's correct. Okay? So again, if it's a positive angle measure, you can add 360, and even if it was a negative angle measure, could I add 360?
Yeah.
Yeah. So our solution to find coterminal angles is to add 360 degrees. That's kind of the rule or the strategy. So to find another way to get there, add 360, because it's just going to take you a bonus spin, and then it's going to take you to that same spot. Does that make sense?
Yes.
Okay, so it's the same picture, but again, how you got there was different. All right, I'm going to stop the video.